Welcome to the channel of Advanced Mathematics to learn the topic of Algebra. In this topic of Algebra, I will continue with subtopic number 3 on logarithm. And today, I will explain part D, laws of logarithm. These laws of logarithm help us to simplify logarithmic expression and to solve logarithmic equation. And the following are basic laws of logarithm. Roman 1 is inverse property of logarithm. Roman 2 is first law of logarithm, is well known as product rule law. Roman 3 is second law of logarithm, as well known as quotient rule law. Roman 4 is third law of logarithm, as well known as power rule. Roman 5 is change of base rule. Roman 6 is identity rule. Identity rule, as well known as the log of base. Log of base. Roman 7 is zero rule. Roman 7 is zero rule, as well known as log of 1. Roman 8 is reciprocal rule. Reciprocal rule. In this session, I will explain the law known as inverse property of logarithm. Today, I will explain the law known as inverse property of logarithm. In this law, I will cover the following parts. A will be definition of inverse property of logarithm. B will be derivation of inverse property of logarithm, and C will be solved examples on inverse property of logarithm. Okay, let me begin with A, definition of inverse property of logarithm. We define inverse property of logarithm in two ways. First way is log of b raised to the power of x to base b is equal to x. And in a second way is b raised to the power of log of x to base b is equal to x. In both ways, the condition is when the base of logarithm b, and here is b, is equal to the base of exponential function. This is exponential function with base b, and this is exponential function with base b. Now, when base of exponential function is the same as the base of logarithm, which are all b, then the result here is the power of exponential function, which is x. And in other way, when the base of exponential function is the same as the base of logarithm, then the result is a given number of the logarithm, which is x. This is how we define inverse property of logarithm. The other form of this definition are log of 10 raised to x plus 1. This is equal to x plus 1. Why is this? Because this log is common logarithm with base 10, and this exponential function is base 10. Then, as long as these bases are equal, then the result is the power of exponential function, which is x plus 1. As well, we can write this as log of c raised to 9x plus 1 to base c is equal to 9x plus 1. Okay, let's consider this form. We can write this as well in other form as b raised to log of x squared plus 1 to base b is equal to, as long as this base of logarithm is the same as the base of exponential function, then the result is x squared plus 1. As well, you can write this one as 10 raised to log of 9x plus 1 as the result is 9x plus 1. Why? Because the base of exponential function is 10 and the base of logarithm is 10 because it is a common logarithm. Okay, let me continue with part B, derivation of inverse property of logarithm. Derivation of inverse property of logarithm. B. Derivation of inverse property of logarithm. Here, required to derive is log of b raised to the power of x to base b is equal to x, and b raised to log of x to base b is equal to x. We want to derive these two conditions. We want to derive these two conditions. This and this one. Okay. First, because we are dealing with inverse property of logarithm. In order to get the logarithm from exponent, we must find the inverse of exponent. And in order to get exponent from logarithm, we find the inverse of logarithm. Now consider the following exponential function. F of x is equal to b raised to the power of x. Find the inverse of f of x. Okay, the first step in finding the inverse of any function is to change the variable. F of x is the same as y is equal to b raised to the power of x. So first step is change the variable. Now y becomes x and b raised to the power of x becomes y. Second step in finding the inverse of any function is to make y the subject. Make y the subject. Now we have, in order to make y a subject, I must write this equation to its equivalent logarithmic form, which is power is y is equal to log of given number, which is x, to base b. And I call this equation is g of x is equal to log of x to base b. Therefore, the inverse of f of x is equal to b raised to the power of x is g of x is equal to log of x to base b. Okay, now there is a condition in function. This condition speaks out when two inverses are composed, they equal to x. And the composition operator is this one within these brackets. When two inverses are composed, they equal to x. Here we have two inverses. The first inverse is f of x is equal to b raised to the power of x. And the second inverse is g of x is equal to log of x to base b. Now, we must compose these two inverses. The maximum way of composing these two inverses are two. The first way is to take composition of g of f of x. This is equal to x. But what is g? G is log to base b of, where x I put b of x. So now in left hand side we have x, and in the right hand side we have log of b raised to the power of x to base b. Therefore, log of b raised to the power of x to base b is equal to x. We derive the first condition, and as well, when I use other way of composing these two inverses, which is I start with f of g of x, this is equal to x. And what is f? F is b raised to the power of x, where x I put g of x, which is log of x to base b. Log of x to base b. Now, in left hand side, I have x, and in right hand side, I have b raised to log of x to base b. Therefore, b raised to log of x to base b is equal to x. And this is a second way, which is a condition for inverse property of logarithm. Okay, we derive the inverse property of logarithm. Now, let's see some examples concerning the inverse property of logarithm. Part C, solved examples on inverse property of logarithm. Part C, solved examples on inverse property of logarithm. A, simplify 100 raised to log of x square plus 1. B, log of 100 to base x. Solution. A, 100 raised to log of x square plus 1. This is the same as 100 raised to log of x square plus 1 to base 10. This is common logarithm. Now, in order to simplify with help of inverse property of logarithm, I must write the base of exponential function in terms of base 10. Now, I have 10 square raised to the power of log of x square plus 1 to base 10. Now we have 10 2 times log of x square plus 1 to base 10. This is the same as 2 comes here. Now we have 10 raised to log of x square plus 1 square to base 10. So as long as the base of logarithm is the same as the base of exponential function, then the result is this one, which is equal to x square plus 1 square. When we expand this, we get x raised to the power of 4 plus 2x square plus 1. Okay, let's consider example B. Example B is log of 100 raised to power x. This is equal to log of 100 raised to the power x to base 10. This is common logarithm. In order to simplify this expression with help of inverse property of logarithm, I must write the base of exponential function in terms of base 10. So this is log of 10 square to power x to base 10. So this is the same as, this is equal to log of 10 raised to power 2x to base 10. As long as the base of logarithm is the same as the base of exponential function, then the result is 2x. Thank you.